welcome to the second video in this series of tutorials on fractions. I recommend before you watch this to watch the first tutorial in this particular set, which was quite a long tutorial where I really carefully tried to introduce the concept of a fraction with some examples. It was all birthday cakes, but that's quite a useful way to introduce the ideas. And I also talked about converting between mixed numbers and top-heavy or improper fractions. So in this tutorial, I want to take on another important manipulation with fractions, which is simplifying fractions. And then in forthcoming tutorials, I'll talk about arithmetic with fractions, namely multiplying, adding, and so on. So, fractions continued. And again, here we'll be talking about simplifying fractions, which is a very important and useful thing to do. Let me just review with you the example I used in the last tutorial. So we have a birthday party. The host has invited 2 guests. The host has cut up the cake into 3 very large, rather yummy slices there. So each guest is due to have a slice which is 1/3 of the cake. Just as a slight side remark here, notice that 1 cake is 3 slices. That is 3 lots of 1/3 of the cake. So 3 times 1/3 is equal to 1. And as we saw last time, we're happy to write this as 3/3. So you're always free to write a number divided by itself as 1, or alternatively you can write 1 as a number divided by itself. And there are an infinite number of ways that you can write 1, therefore, because let's say we were talking about a cake with 10 slices, we could simply have written that 10 slices, namely 10/10, is equal to 1 cake. And so it's quite a good thing to get used to, which is that a number divided by itself is equal to 1. Back to our party here though, so a slice is 1/3 of a cake. One of the guests has been rather rude and without telling the host has brought along 3 friends. And the host is very generous and does not mind. And now there being 6 people in all, the host divides up each of the big slices into 2 smaller ones. And you see now, to accommodate the 6 guests, the cake now has 6 slices, so a new slice now is equal to 1/6 of the cake. Just going to partition off this little side remark here. In case you're reviewing the notes later, that might be confusing. Right, so if you just humour me here with the stories. So, turns out though that 2 of the guests are lactose intolerant and the host has been using some milk in making the cake and therefore they can't have the cake, so only 4 people can eat the cake. So the host has a slice and 3 other guests eat their slices, and that is the amount of cake that is being eaten. So that shaded area is equal to 4 of these 6 slices, is equal to 4/6. But we also see, if we just looked at the old slices before the other guests came, what's been eaten are 2 of the large slices, of which there were formerly 3. So we know that that amount of cake is also equal to 2/3. So here's this really nice, hopefully clear example where we see that there is no difference between 4/6 and 2/3. They have the same value. And the manipulation that you would do to show this, or to go from here to here, is the following. You would take your 4/6 and you would write 4 as 2 times 2, and you would write 6 as 2 times 3. Now, when you have quantities multiplying each other in maths, we call that factors. So in the top of this fraction we have 2 factors, 2 and 2, and in the bottom of this fraction we have 2 factors, 2 and 3. And when you're manipulating or simplifying fractions, if you can write both the top and the bottom as a set of factors that are multiplying each other, if you can identify common factors, namely factors which are the same on the top and the bottom, then you can cancel them. And we see there, by cancelling the common factor of 2 on the top and the bottom, we are left with 2 divided by 3, 2/3. And that is the way that you would manipulate this fraction of 4/6 to get the fraction 2/3. The story and the picture simply illustrates conceptually why it's true. This would be the manipulation that you would do to go from 4/6 to 2/3. Let's think of another example. Let's think of 2 soccer teams. Now in soccer, which is called football in the UK, in soccer each team has 11 players. Let's say that there is a red team and a blue team. Okay. Now if you ask the question, what fraction of players wear red on the pitch? Well, you could say it is, there are 11 players wearing red out of a total of 22 players. On the other hand, though, you might cut to the chase and say, well, there are 2 teams, there's a red team and a blue team, and one team wears red, therefore the fraction of players wearing red, sorry, I have to say wearing red there, the fraction of players wearing red would simply be 1 red team divided by the total of 2 teams on the pitch. And so again, from this simple example, we see that 11 over 22 is numerically equal to 1/2. And the manipulation we would do to go from here to here is to say that 11 over 22 is 11 times 1 on the top and 11 times 2 on the bottom, because 11 2s are 22. And you see we have a common factor, in this case 11, which we can strike out, and we are left with 1/2. And that is the way that we would go from 11 over 22 to 1/2. I'll just give one final example before ending this tutorial. Let's think about an hour being 60 minutes. And you could say the fraction of an hour. What fraction of an hour is 15 minutes? Well, 15 minutes, and how many minutes are there in an hour? Well, there are 60, so that would be the answer. But another way to think about that would be to say, well, commonly we think of 15 minutes as a quarter of an hour, and so if someone asked you what fraction of an hour is 15 minutes, you would probably very naturally say, well, it's 1 of the 4/4 of an hour. And so intuitively it's very clear that this fraction of 15/60 is equal to 1/4. Mathematically, how would we show that? Again, we would write common factors down. We can write 15 as 15 times 1. We can write 60 as 15 times 4. We see we have a common factor on the top and the bottom. We can strike these out and we are left with 1/4. So let me end here. I hope this has been helpful. We've sort of given 3 scenarios, a cake, soccer teams, and time in 1 hour, to give examples where very clearly we can see a relationship between 2 different fractions. And then I've just taken you through the manipulation you would do in terms of writing the top and the bottom in terms of factors, and then seeking a common factor that you can strike through, and the remaining factors then make up your new fraction. And that is how you simplify fractions. Next tutorial, we're going to leap into arithmetic with fractions, and I look forward to seeing you then. Thank you and goodbye.